well, we said right now we can't get the x-intercept.
Oh, so you just did
But you can only do it on your calculator. With the zero, I told you yesterday, you can only do it with the zeros on your calculator right now. All right. Now, this guy, I want you to get used to drawing these and just sketch them, and do the transformations. All your transformations always work the same. Think of this. So, Alasia, if I do this is my basic parabola, right? What does it mean when I say -4? Where's this guy going to go? This is a vertical. Outside of the x is a vertical. It's going to go down 4. So it's the same thing here. This is now like my x squared. This is my exponential one. This is my vertical shift down 4. Now, if you have trouble visualizing this, you can use your calculator. Watch. Just put your basic curve in. 3 raised to the x. And then down here, put your transformation in. God bless you. -4. And see what's happening here. If you want, make your first curve dark so that you always can make your transformations off of that. Just hit it once. Now watch. I'll just do a 6 here. Here's my basic curve. It doesn't fall below that line. Your calculator just can't get any closer. But look what it did. From here, didn't it shift it down 4? Can you see where the 0, 1 is? Yeah. If I could keep track of this point, this is my 0, 1 point. That's my y-intercept. This is the easiest way to do this. Watch. Memorize what the domain and the range is of your basic curve. Your basic curve. What's the domain? Well, I can use any x value that I like. What range? Yes, I'll never touch this 0 line because isn't that my natural asymptote? That's my asymptote. Now, watch. Here's my transformation. 3 to the x -4. Everything's going to shift 4 units down. So this point 0, 1, I'm going to say, oh, subtract 4 from that 1. It's going to come to 0, -3. This 1 is going to move down. It's now going to be at y equals -4. Everything moves down. So I'm going to make my function, so I'm passing through that and going up. That's it. My range dropped 4. My new range, -4 to infinity. My new asymptote, y equals -4. Work it off of your regular ones. I think it's easier without your calculator. Like when I look at my calculator, where am I going exactly? Because you can't see your asymptote. What you can do is put this in. So y equals 0 is my original 1. I can put in my y3, y equals -4. There's my new asymptote. And again, your calculator doesn't do it justice. It looks like it's writing over the asymptote line, but it is not. It is getting very, very close to it, but does not write over it. Doesn't come over that line. Okay, so that's what I was hoping that you would get out of these. Right now, for the y-intercept, anytime you want to find what crosses the y, the x is 0. So you could very easily substitute in an x of 0. 3 to the 0 -4. Anything to the 0 power is 1. 1 -4, -3. And we found that also physically by dropping this 4 steps back down. Yes? The power of the x?
Yeah, like 3 to the x is always
For an intercept? For a y-intercept?
No, like 3x minus 4, the x is always going to be 0.
No, this is going to change. That's what's going to vary this time. That's your variable. So technically you have a graph like this. Here's x, here's y. You're going to substitute these in. So you're going to put -2 in here. This is going to flip it over, give you 1/9. You're going to put -1 in here, 1/3. You're going to put a 0. Oh, that's 1. You're going to put a 1 in here, 3. A 2 in here. See, that's where your points come from. But we just sketch, because they're all going to follow the same sketch. Your core graphs, whether they're 2 to the x, 3 to the x, 5 to the x, they get a little narrower to the axis as it increases, but it still has the basic sketch. I'm still not understanding what you mean by 0. To make the y-intercept?
Yeah.
Yeah, the y-intercept x is always 0, because that's this line here. So where does it cross my y-intercept? When x is 0, what is y? Y is, at this point, if we didn't have that, if we didn't have a transformation, we just had a regular one, then y would be 1. If I do this, then y is -3. It jumped from here down to here. And everything just slid down 4 units. It has the same effect that all our other transformations have. Okay? This guy, start with your basic graph. I think it's easier to do the graph step by step. Let's put some color in here. All right, so now we start with your basic graph. Your core graph is 2 to the x. So start just with the sketch, 2 to the x. Basic functions. All your cores work the same. Your intercept point and your asymptote. This is the information you need for all your core graphs. Now, following order of operations, if I was to plug a value in for x, the first thing I would do is raise it and then take the negative of this. So when the negative is out here, where is my reflection? It's not saying negative x to positive x, it's saying negative y to positive y. So it's going to do a reflection in the x-axis. So it's going to come like this. This is now going to be 0, -1. Did I change my asymptote? Did I change my range? My range now comes up to here and says, whoops, it's backwards now because we reflected. It's -infinity to 0. Okay, so that changed. From there, from that red one, I am going to now do what? Move it up how many units? 3. So everybody moves up 3 units. So watch. I'm going to add 3 to this. What's that point going to be? -1 plus 3. 2. That's where my intercept is going. This was y equals 0. I'm going to move it up 3. What's my asymptote going to be? Y equals 3. Everybody just moves up. So now it's going to look like this. So my range also moved up 3. My range says -infinity to 3. This is my final range for this. It's my final asymptote, my final point in here. Okay? It makes a difference when you shift and when you reflect in this one. You've got to follow order of operations. And I personally find it easier to sketch each part. If you do it on your calculator, let me show you a little hint here. Watch. Do one step at a time. Do one step at a time. Here's your basic core graph. Let's make this 2. That's your basic core graph. Come down here and just do one thing. Just put in the negative. What does the negative show me? So I got a basic core graph. Here's my graph. I got a negative. Oh, what did it do? My negative did a reflection. Do you see it? Do one step at a time. Okay, now that you know you did a reflection, now come down here and add the next step to it. If you need to do this, you should be able to do this without a calculator. So I knew I had the reflection. I was here. And then maybe I want to make sure that I go up. There's my intercept right there. You can look at your table. When x is 0, what's my y? 2. See it? You can't do your x one algebraically yet because we haven't done logs. If you want your x-intercept, you can always do a 0 on this. Second calc, number 2 for zeros. But you've got to flip over to this guy and isolate it. From here to here. You can get a 0 on this, if you so desire. I didn't really need you to do it because we do them algebraically, but right now you didn't do logs yet. Good? Yeah. All right, next one. What's my basic chord graph? Base of what? 4 to the x. Looks the same, doesn't it? It's a little closer to the y-axis, but basic sketch. Basic functions. I've got negative infinity to infinity, 0 to infinity on my range. My y-asymptote is y equals 0, and my intercept is still 0, 1. So now, when I'm next to the x, that means I have a horizontal shift. It goes the opposite way. The same thing if I did this. Instead of doing x squared, I'm doing x, instead of doing x squared, over this way. It was next to my x. Say this is my graph. So that would be next to my x. When it's next to your x, it's horizontal. A horizontal shift is not going to change your asymptote, is not going to change your range. It will change your y-intercept. So we shifted left 3. We just moved this over 3. Okay, I went to negative 3, 0. Here's I'm at my dotted line. Then where did we go? Down 2 units. If I'm at negative 3, 1, and I went down 2 units, I'm here at the negative 3, negative 1. What's nice about this point is, even though it's not an intercept, if you graph this thing, you should see this point. It'll be there. To find your y-intercept, just let x equal 0. Plug it in, and it's going to intersect way, way up there. This is the guy that made your asymptote change. It dropped it down 2 units. This is what made your range change. It dropped it down 2 units. There's my new range. My domain, no effect, because I'm all real numbers. Good? Yes. The x-intercept, you have to find this with your calculator right now. So if you graph this in your calculator, you can find that point. We can't do it algebraically because if we let y equal 0, the only thing that will bring down that exponent is a log. We just didn't get to logs yet. Well, on the test for exponents, I won't ask you for the x-intercept. When we do logs, then yeah, I will. But right now, like I said the other day, you can do it on your calculator with a second calc 0, like I just did before, so that you can see if you're in the right spot. Base of 5, you've got a base of 5, you have a reflection in your x-axis, and then you have a horizontal shift to the right. And then after that, you're shifting 1 up. The one that's going to change your range and your asymptote is your horizontal shift. Your reflection over the y-axis has no effect on that. So it's just going to change with your vertical. Put x of 0, find your new y-intercept. Again, this didn't have any x-intercept, so you weren't too concerned about it. Are we okay with these? You getting the hang of it?
It's easy.
Did you write any of this down, Elisa? With me? All right. Maybe we could spend a little time on that together. And this just has a whole bunch of things. Pretend you're plugging in for x. So if you substitute in for x, the first thing you're doing is this thing. If you want, take this out, turn it around. that might be a little easier. You've got a reflection and a horizontal shift. Then you have another reflection. This one's close to the y, so that's over your x-axis. The last thing you do is shift up 4. So you have to be able to give me all the transformations in order, using the transformation words. Horizontal shift, reflection over the y-axis, vertical shift. And it should make sense when it's done. Nice.
No, I'm sorry.
Okay? And graph this in your calculator one step at a time if you have to. Graph it one step at a time. Okay, the next part, how'd the next part go? Using your, using your formula? We okay with these? You have to know that formula. N is where it's compounded. Your rate, don't forget to flip to a decimal. 5% is 0.05, not 0.5. In case they give it to you in percents.
Yeah, I have none of these other things. Whoa.
Do you have these problems?
Yeah.
So, do you have this substitution in here?
Put a 1 under each percent.
Oh, that's right. Sorry.
All right, let's take a look at the first one. I can guarantee you, were you using the 83 calculators, the black ones? You have that one? You put it in that one because usually it's right here in the exponent. So let's see what you put in. Did you plug in the 2,000 here? 1 plus, what's your rate? 0.06. Got to say 0.06. Over how many times is it compounded? Quarterly, 4. And I'm going to raise to the n, 4 times how many years? 4. Now, try it in your calculator again. Put it in directly. Don't put it in your y equals. Put it right into your calculator.
Why do you do 4 times 4?
Because it's n is 4, t is 4.
Oh, okay. Now I know why I screwed up. I don't know why I care. I know why.
Maybe it just was odd because they were both the same number.
Is that what it is? Okay.
Now be careful. On the 83s, when you do this, on the 83s, you're going to say 2,000, 1 plus, this follows order of operations, that's not a problem. But here's the problem. If you do 4 times 4, this is what your calculator is going to do. It's going to raise everything here to the 4th power, multiply by 2,000, then it's going to multiply by 4. And that's not what you want. So on the 83s, guys, you need parentheses over here. The 84s, they move you up to the exponent, so you don't have a problem.
I'm good now.
We're good? Okay. How about the rest of these? Well, if you know where your problem is, though, now you know what you did wrong, right? So let me just whiz through these answers. And the last one was a perk, because I gave you use base E.
You do the last one, right?
Yes? The last one, here's how many times you compound. That means continuously. So continuously has its own formula. We call it PERT.
Oh.
P-E-R-T. Principal, base E raised to the 0.07 times 6. Everything's just plugging them in. Your first one says, what is the value of an initial investment of $2,575? This is your initial investment. This is your P. At 8%, this is your rate. Compounded continuously. And for 6 years, this is your time. So which formula am I using? P-E-R-T. Good. Just pull out what you have. What's P?
60.
P. Principal.
2,500.
Oh, they said T.
P. Then E. What's R? Good. 0.08. Flip this to a decimal. Don't put 8 in there. You're going to make a whole lot of money. And then what else goes in here? What's my time? 6 years. Now, do I have anything that I need to know to be able to just not put this in my calculator? Can I just put this in my calculator? Just like we've been doing? So just go put this in your calculator. Dollars round to how many decimals? 2.
So $4,161.39.
Very good. At the end of my 6 years, it's a nice little chunk of change. If I could put this money in now, if I had 8% compounded continuously, I would make $4,160. I'd have $4,161.39 in there. I will have A means accrued. God bless you. Accrued. I will have exactly that much money in there in that bank after 6 years. Same thing we've been doing, right? Now, sometimes we're missing a couple of things. Determine when an investment of $2,300, this is the principal, accumulates, oh, this is the A, to a value of this if the investment earns an interest rate of 9% is compounded quarterly. So let's put in what we know. What's A? Do we know A?
Yes.
Yeah, what is it?
4150.
Good. I want to know when I'm going to make this much money from my little investment of $2,300. What's my rate? 0.09. What's my compounding? 4. And N times ups. That's the guy I need to know. It's my time. When? This is my time. This is what I'm missing.
What's the 1 plus?
1 plus, that's from your formula. We're still going to use your formula. Now, you can't put that in. Now, this one's compounded quarterly. Hers is only when it's compounded continuously. Now, here's the problem. The only way to get an exponent down that's variable is a log statement. We didn't do logs yet, so we're solving this graphically. So graphically, we're going to put this in our y1, we're going to put this in our y2, and we're going to see where they intersect. They all work off of this, guys. Watch up here for a second. This is my basic format. This is my initial value. This is my rate. This is my time. All of your graphs are going to either be increasing or they're going to be decreasing. They're going to all look like this. The applications say, well, you can't use this quadrant because you can't have negative time. Time is your x value. So this puts us into quadrant 1 whenever we do an application. So let's put this in our calculator. I'll do this with you. Let's see what we get. We may have to change your window, right? Because we're looking at large numbers. So first one, we're going to put in the right side of this equation. 2,300, stay with me on this. 1 plus, just like you read it, just like you would do this without the graph. Raised, and we use the x still. Raised to the 4x. Now, 4150 goes in my y2.
Does it matter what you put in?
No, you can put it in y1 and then y2. Yeah, no. Now, here's my problem. I'm not going to see a graph on this guy. I got some large numbers in there. So let's take a look at your window. We said, it's still churning, we said both of my mins should be 0 because I'm in the first quadrant. My x max is my time. I don't know how much time this is going to take to accrue this money. Let me just leave 10 in there for now. My y max, who knows what my y max should be? 5,000. And what made you say that, Denise? The A max that we're trying to reach is 4150. So if we want to see where they intersect, go a little bit above it. You're just giving it a window. So 5,000 is perfectly fine. Don't sweat out. Should I make it 4350, 4250? Just go 4,500, 5,000. Your goal is to see this. Here's your money growing. It's growing exponentially. It came from this quadrant over here. Here's your goal here, 4150. I want to find where they intersect. So, second, calc, which number? 5. And on an intersect, you're just going to hit it 3 times. 1, 2, 3. There's my answer. So my answer is, see, there's your 4150. This is your x value. This is how long this is going to take you. 6.631 years. Okay. It's going to take me 6.631 years for my money to accrue to make me 4150. My variable this time was in my exponent. I couldn't put everything in my calculator. But I can graph it and find it right now. We will revisit these after the break when we do logs, because then a log will allow us to pull down that variable. Okay, number 3 is just like that.
We did the same thing.
Number 3 is just exactly like that, except of course the numbers changed a little bit. But take a look at number 4. Let's look at number 4. Okay, determine when. So when I have to determine when, what is my variable? Time, good. Time I don't know. An investment doubles in value at 6%. There's my rate. Compounded continuously. Gabe, what formula? Continuously. Per. Good. All right. So now, let me plug in my values. What's P? Oh, they didn't tell us. They said it doubles. So give me any value. How much? No, just a number.
22.
1,000. Let's go with 1,000. Let me just put this here for a second. So when I double 1,000, what will it be? 2,000. Okay? So now, this goes with my E, not my 1,000. So watch what happens. If I divide both sides by 1,000, oh, sorry, this is a 1,000. This becomes 2 to 1. So when you're doubling, easiest way to do it is this is 1, this is 2. What if I triple? What should it say? 3 to 1. Aren't I tripling 3 to 1? No matter what numbers I put in here, if I put in 500,
That's all you have to do.
no, we're going to solve it in a second. What is 500 doubled? 1,000. So this belongs here. So if I divide by 500, there's my double. 2 to 1. You can put in any value you like. You got to change your window a little bit more. So when E was a 1 to 2, you can use a smaller window. So we're going to take this value and we're going to finish working with this. So 2 is equal to, I'm going to put the 1 just so that you see it. What's my rate? 0.06, and my time is what I don't know. So here's my y1, here's my y2. I can't pull down an exponent variable unless I use a log scale. So right now, we're going to graph it. So we're going to graph these two things. And it's a very small window, so just go back to a zoom 6 and let's start again. So we're going to get E raised to the 0.06x. And your second one is just going to say 2. Now, do a zoom 6. It's coming from quadrant 2, but the one I want is in quadrant 1. So I'm going to change my window just to give me zeros. I'm just going to do this one step at a time so that you can see this. Get to the first quadrant. Graph it. Here's my money growing. There's my value. Yeah, I'm not so sure that it touched there yet, right? So if they didn't intersect, I need to see a little bit more over here. What do I need to change in my window? X. X what? Min or max? Max. So rule of thumb, I like to double it. What happens when you double it also, you'll see more of a curve here. You kind of see more of a curve now and you're growing. And can I do an intersect on this now? Absolutely. So again, intersect, first curve, second curve, guess. It's going to take me 11.552 years. To make my money double. No matter what I invested, it will double at that rate, compounded continuously, in 2 years. So you have to finish this one.
Instead of 1 before, which is compounded monthly, it's just added over 12.
Over 12. And then your exponent also has 12x. Okay. These should go okay. Watch 5 and 6. How about if we do 5? Can we do 5?
Yeah.
5 is there. It's just what we're looking for is a small number. Okay? An investment earns, this is my investment, this is my P, interest compounded annually. What is N? 1. Determine the annual rate. If the value is $3,000 after 8 years, there's my time, there's my accrued. So let's start like this first. Let's put in what we know. What did we accrue? 3,000. God bless. What did we invest? 1580. Okay, 1 plus, what's my rate? We don't know. Call this R. What's my N? 1. And 1 times, what's my years? 8. So let's simplify this a little bit. 3,000. 1 plus R to the 8 power. Now, I need to know my rate. This is where my X is going to go. This is my Y2. This is still going to be my Y1. So let's put that in. What kind of number is a rate? A decimal. So let's think about that for a second. If I'm looking for a decimal, like if 8% is 0.08, I'm going to have to set my X a little bit differently. Let's get this in first. That's where your X goes. Raised to the 8. And we want to match up to 3,000. So let's take a look at our window. Our mins are zeros. My X now represents my rate. And you just told me it's a decimal. So what do I want to make my X range go from? 0 to 1. Good. 1 would give me 100%, right? I seriously doubt anyone would ever pay me 100% to increase my money. So we're going to take a look at this. Now, your Y max, what's the highest you want to go to on here? 3,000. Let's make it 3,400. You're just giving me a window. And we want to see where they intersect. Now, can you do an intersect on this and find the rate? This, yes. So look at my percent. 0.0834 is the same as a little bit more than 8%, isn't it? Because now I flip my decimal the other way. Now, watch for a second. Watch what's going to happen here. if I didn't realize that I had to go from 0 to 1, watch what happens when I go to 0 to 10. I don't know what happens in my graph, but I have the second one there, right, where I'm intersecting with 3,000. Now watch. Second, intersect. First, second, guess. It found it. It found it, because where was it? It was less than 1. It was so close to my y-axis, I couldn't see it. My calculator doesn't do a very good job with it, but it's there. You can still do an intersect. All right, so you guys don't have too many more to do, but I want them completed.